Hi, welcome to my channel, and in this video we're going to learn about how to create and simulate new project within Xilinx ISE design suite. So first of all, you should be having a Xilinx ISE design suite, right? So if not, here is the link. How can you download it? On Google, you just simply need to type in Xilinx ISE download, and the first link is going to take to their official website where all the downloads are available. So here are multiple versions that they were being used. So I have one of the version downloaded already, so you can go and download any version that you like to. And I have this particular 14.1 version downloaded. So here have different options to download this particular package as well. So you just have to need to simply download and install it as like any software that we do, right? So in here I'm going to talk about how can you create new project in Xilinx design. So I have Xilinx installed, so I need to turn that on. ISE, just you need to write down ISE. ISE, yeah. So we have this Xilinx design ISE design suite, right? And it is 14.1 that I am using. So you just need to open it simply, and it is going to open with the previous closed project. That's what it shows. And if this is a trial version, as you have downloaded, since we don't have license for it, it is not going to allow you to open existing projects. It is only going to allow you to create new projects. Like for example, if this project is closed, this is what window you're going to see, and it is not going to allow us to open any existing project. So that's the difficulty with the trial versions, but that's okay. The license is of lakhs of rupees, so just for trial you can download the trial version and start using this. Just the thing is that we need to create new project all the time. So that's what I'm going to do now. So just simply need to click on new project, and in new project it is going to give us some options that what to do now. Now here I've created a folder called project 2021 2122, and here I'm going to create another folder called let's give it a name. For example, logic gate. In this particular project we'll do logic gate example. So logic gate, I'll give it a name as folder, because it's a good practice that if you give a different name to your project other than your folder, that will help, because anyway it is going to create another folder in here. Okay, so this is a good practice to have one folder above, just for simplicity's sake, so that you can have multiple folders of multiple projects. So here we need to select HDL language, as we are going to do with Verilog HDL. Next, here is the space where you can select your particular family, that the FPGA that you are going to use for this particular project. So here also they have a few evolutions board that they develop. Xilinx have already developed. So here you have multiple options for those boards as well. If you have you happen to have boards designed by Xilinx, so you can directly come over here and start using those boards. But otherwise, since I have Mima's board with me, so, and that particular board is of Spartan 6 and with this particular device, and this is the package. So I purposefully selected this family, device and package, right? And here you need to mention that you're going to use VHDL or Verilog, and here also we need to select this VHDL and Verilog, and that's it for here. And we are good to go, and our project will get created. So that's it. Simply it's going to create a project. Now this is what your project window is going to look like. This is an implementation part, and here is the simulation. Shortly we're going to do that, but we need to have a space where you can write your code. Okay, so how can you do that? Is just click here on that project and right click and new source. So here we are going to select our source file, and this particular project is going to be done on Verilog and not on HDL model. So I'll select Verilog model, and I'm going to give some specific name. So let's give it a name as meaningful. Like for example, I'm going to do this is for logic gates. So I'll give this name as logic gate. Let's give the same name as that of project. It will ease us, identifying multiple V files. I mean, like when you have multiple projects designed, and if you give some common name as main.v or top level.v, that will create difficulty in differentiating multiple project files when you search them. Okay, so that's what that's my practice. I give same name as that of project to my main file, that is logic gate .v, and this is going to be our model name as well, Verilog module name rather. And here we need to select what all inputs do you want to have and what all outputs we'll be having. So this project is specifically for gates, so let's give them an input and with one bit input, and let's give name as that of gates itself, so that it will be easy for us to identify the signal, right? So this is what is called a signal name, and it is an input. This is an input. Shortly we'll make this as output. Let's what all other gates do we have as say not, and next is NOR, or best is XOR, and then we have NAND, NOR. Okay, so we're going to simulate all our gates within this same function, and as the 6 are going to be our output, so I'm going to make them as output. There is another possibility that this same signal could be an in and out, right? So as for now this is an output, so I'm going to make them as output. Absolutely right. So we have got 2 inputs and 6 outputs. So let's create our V file. This is the summary of what input and output we have selected. Awesome. Yeah, so this has created me a file where I have all the inputs and outputs listed over here. This is an input, this is what model, this is the syntax for Verilog module, right? So here is the name as module, name of that module, and what all input and outputs do we have. We need to differentiate it with single comma, right? And at the end there is no comma, and end module, that means we are going to end this module. So whatever we wanted to do is we'll be doing in this space, right? And this is a very simple project where I am expecting to have this output signal as of this operation, that is A and B, because I have given a specific name so that I could identify what that operation is going to be, right? So we'll be using this assign statement. So assign statement is nothing but whenever this side of this signal gets changes, it is going to get reflected within this. Okay, and assign is specifically used when you wanted to write on the wires and not on the registers. So in upcoming videos we could see what is register, what is wire, but all the inputs and all the outputs are considered as wires. So if you wanted to write on wire, right, so we need to use this assign statement. So I'm going to use this assign statement, and let's create all of the gates. So I have this OR, I have this NOT, then XOR, NAND, NOR. Okay, that is it, and let's give them an operation. So OR is nothing but this, right? Not now we can not only one signal and not both of them. So what I'm going to do is let's keep this as it is. So this is the not symbol, this is the or symbol, this is the and symbol, and here is my XOR symbol has to be like this. NAND is nothing but I'm going to invert the AND logic, so I need to give the bracket over there. Here is again simple, I'm going to do is NOR and not the OR. Okay, this is how simple it is to write your Verilog module. It is nearby as good as C, right? So few syntax here and there, but it is as good as C. So we need to implement our design first, and then only we would be able to simulate it, because here is what it is going to check for all the syntaxes, syntax errors, and if there is no syntax error, it is going to build a circuit of this particular logic. Okay, so what is needed now, we need to select it, select at the V file, and we'll do as this, that is implement design, and we're going to say as run all. So it is going to run me these two objects, that is, it's going to synthesize and it is going to check for all the syntax errors and all the possible wrong ways that a code could be, and if not, it is going to give a green tick mark somewhere at this point. Okay, and if it goes green, that means we are good to go for the simulation. So let's wait until this compilation process completes. It is my observation that this particular implement design stage takes longer time, because here actually it is going to create a schematic of this particular code, right? So it takes much of the time, so be patient. Awesome. So we have our synthesize process done and implement design stage done. Okay, so we have got this placement, route and translate, map, place and route, all things done. So we are good to go for the simulation, and here it actually also generates a bin file, or a .bin file rather, which is executable on FPGAs. So that's not in the scope of this video, so no worries. Let's start with the simulation. Okay, so here you could see this is an implement tab, and here is a simulation tab. So here I click simulation, and you need to click on the Verilog file. Okay, so that it opens. So otherwise, if you click here and there, it is going to show some different options. So it's better to click on logicget.v, and here we have our simulators ready. So here also we are going to do is right click on this and run all, and it will create us another window where it will give us the option for us to simulate, and that's what we are going to do now. Awesome. So we have this simulation window ready, and here are all our signals listed as this, that is A and B, and this X means they are in tri-states, not 0, not 1. This is also in tri-state. This is output tri-state, this is input tri-state. Okay, so here we need to give some input to our signals, okay, not to the output signals, to the input signals. So there are multiple ways of doing it, that is you just need to right click on that particular signal, and here we have these options. This force constant, you can force the constant value on that particular signal, or you can give a force clock. So in this particular example, we are going to do is we are going to force the clock. So here I have there are multiple options, that whether I should be giving my input in binary, in hexadecimal, unit, unsigned decimal, signed decimal, and whatsoever. Okay, so as this is a single bit signal, I'm definitely going to prefer it to be on binary value. So I've selected binary. What leading edge signal do you want to have? I mean, like it could be 0 or 1. Okay, it doesn't matter if unless and until you have very specific reason of doing any particular signal. So I prefer it doing 0, trailing edge would be 1, and how much time do I want to run this? Okay, I want it to be running until 1 millisecond, so that's what cancel after time offset. Yeah, and period. So how much should be your period of a wave? I mean, like there will be square wave, right? And the off period, that is the high period and the low period, combining, adding both them will create your period. Okay, so you need to mention what period you should be having this cycle for, right? So I'm going to make this as 100 nanoseconds. So let's make this as 100 nanosecond, and this is a 50% duty cycle. So exactly 50 nanoseconds high, 50 nanoseconds low, right? So apply, and okay, so we have done with input A. We'll do same thing as for B. So I prefer this as 0, this is 1. Let's do this for 1 millisecond, and here I'm going to change the timing of the signals, because if they are given same period, same length and everything, so both signals will look identical, and for testing the gates we should be having some differences between two inputs, right? So how can I make that differences? By reducing the period, 90 nanoseconds. So let's make this as 90 nanoseconds. So 90 nanosecond, this period is going to be for 90 nanoseconds, and above is in bigger period, that is in 100 nanoseconds. So let's apply this. Yeah, so we have given input to input value, input force clock to A and B, and we need not to worry about this outputs, because they are going to get generated within the code. So we need to just run this code, and here are multiple options that if you want to run for continuously run, or do you want to run it for a particular period of time. So I prefer doing it in this way, that is you need to give what value, until what value this simulation should run, because it will over at a particular time instance, and if you do it this way, it will take long and long. It will keep simulating and keep simulating, unless you press stop or it hangs up. Okay, so I prefer it doing this time for this particular time instant, and here is this button, to mention how long this should run, and you need to press this. So I'm going to press this, and yeah, absolutely. So this has simulated me all of the logics, right? So but I'm not seeing what value A has, what value B has. It shows some 0, this tri-state, but if you need to check, we need to zoom out a little bit. Okay, zoom out a little bit. So here I am zooming out my signal. Yes, so awesome. So this is how I have zoomed out my signal. Okay, this is how I zoom out my signal, and yeah, right. So zoom in. Now if I take these two signals as my input, right? This A is low at this point, B is high at this point. So AND is going to be 0, because if they both are 1, this shows 1, right? So here it is showing me 1 at this point. Okay, at this point, this particular instance, since they are both 1, it is AND. And in OR, what happens if one of them is 1, it is going to be a 1. Like for example, this OR is 1 for until this period, right? Not is nothing but negation of A, right? Negation of A. So A is high here and not is low here. That means it is functioning as expected. Then here we have this XOR. XOR means whenever they both are same, whenever they are differences, there is going to be high, and when they are in same, it is going to give you 0. Here is the same. Here both are 0. Here this XOR has become 0. AND is nothing but inverse. NAND is nothing but inverse of AND. So here we have this and this is an inverse of and same is this for NOR. So that means we have seen that we've successfully created new project. We have successfully created new project, and we are able to simulate it. Isn't it that awesome? And you will find a link in the description to download this particular code. So enjoy coding. That is it for this video. Type in the comment box what did you learn out of this video, and I would love to reply all your comments. See you in the next video. Bye bye.